Hi everyone. Unit 4, Day 2, we've got two big ideas to kind of look at today. The first one is restricted domain, and that's looking at special functions where we have to put a restriction or a condition on the domain to make sure that we actually have a fraction. There are three kind of special situations. Situation 1 is fractions. I started to write fractional equations, which would also be okay, but fractions, when they're in equations like this, you remember from Unit 1 that there's only one value that will not work for this particular fraction. The fraction would become undefined if x value were 2. Do you remember when we talked about undefined? We crossed out the top, set the bottom to 0, and then solved it. So if you just took the bottom and set to 0, you would get x equals 2. This is the one value that makes the fraction undefined. It's the one value that will not work. So our domain here is all real numbers except for 2, because 2 is a value that would not work, that would turn the fraction undefined. And this is typically how it's written. The big R with the double bars there standing for all real numbers, and then when you do that slash, that's what that means. All real numbers except 2. Let's show one more. Let's suppose it's like 3 over x squared minus 9. So our domain here, again, we forget about the top. We just set the denominator to 0. If you want to do dots, you can. If you wanted to add the 9 over and then square root, you can. But my roots here are -3 and +3. But those aren't the answers. Those are the things that won't work in this particular expression. So our domain here is all real numbers except positive -3. So for fractions, everything works except the one thing that turns it to become undefined. Another option is to just type it into your y equals menu. And if you type it into y equals and then look on the t-chart, you will see an error message at both 3 and -3. And that's another way to find out, oh, everything works except for those two values because it's giving you an error for the y. So fractions was idea number 1. Idea number 2 is radicals. The idea with radicals is that we can't have any imaginary stuff. Can't have any i's. So basically, you want what's ever underneath the radical to be positive. No negatives under there. Now you still have the option of just typing this in the calculator and looking at the picture like we did in the first day. Whenever we had an equation like a parabola or a line, we made a little sketch and read the domain that way. So that's fine. I mean, you can still do that. And that would be a little less stuff to memorize. So if we do the square root of x minus 2, and just look at the picture, you can see that a radical graph looks kind of like half of a parabola sideways laying down. And can you see where this is going from? From 2 to infinity. So you've got a way of writing the domain from 2 to infinity. Or if you like the set way, you could have just said x is greater than or equal to 2. So you're still, fine with just using the calculator. But it's important to remember that no negatives will work, nothing underneath that radical. So if I, again, look at the t-chart, you see all these error messages, and then as soon as I get to the value of 2, I start getting y numbers. The other thing you can notice is that we talked about that left-right shift last unit with the parabola. It's the same deal here. Even though this looks like -2, it actually moves to the right 2 units. Let's throw one more under here. Suppose I have x plus 7. The domain is going to be x is greater than or equal to -7. Or basically, again, bracket, -7 to infinity. And I know that only because I take what's underneath here and set it to greater than or equal to 0 because it cannot be a negative, and then just move it over. That is my domain. If that's going to bother you, again, just type it into here. What did we do? +7 there? +7. Take a look at it here, and then Either count the ticky marks and recognize, oh, negative and 7 to infinity, or look on your table, and that will also help you. Oh, error, error, all of a sudden this works. Anything greater than 7 or equal to 7 will be a value there. All right, our last restricted domain situation is fractions with radicals on the bottom. So the first one was fractions, the second one was radicals, and now the last one is fractions with radicals on the denominator. So that would be a graph that looks something like that. So what we said for the radicals is that whatever's under here has to be greater or equal to 0. But if it's on the bottom, we also said it cannot equal 0, so you just set to greater than this time, not or equal to. So it's kind of just a combination of rule 1 and rule 2. Whatever's under the radical has to be positive, but if it's underneath the fraction bar, it can't equal 0, so the bar isn't there. So this is my domain, everything greater than -2. Or interval notation would look like -2 to infinity again, except this is a parenthesis this time, not a bar, because it was on the bottom. You can type this one in as well and look on the t-chart, but it doesn't always give you the greatest looking picture of the graph. So really that's why we're even covering this at all. Because sometimes you think, well, I'll just look at the picture every time. These are going to make some kind of strange looking pictures. So I don't know if you can tell, if we're talking left to right for domain, this is -2, and then it keeps going this way forever to infinity. But this -2, it never actually touches, it just gets close here and doesn't touch. Again, when you go here, you'll see the error message. You'll also see things working, but it looks like it starts at -1. It actually is anything greater than -2, even like a little decimal. All right, if it's not one of those situations, radicals, fractions, or fractions with radicals, the domain is all real numbers. Okay, that was idea number 1. Our big idea number 2 today is function notation. Function notation is just that f of x business that you learned in Algebra 1. So you may or may not remember it. You may think, I don't even know why we need an f of x, because they told you probably 10 times f of x is the same as y. And they're correct. F of x is another thing that you can use for y. So if you have an equation like y equals 2x plus 1, and instead I write f of x equals 2x plus 1, it is the same thing. But what f of x does is it lets you ask for a particular y. So if I ask for f of 5, again, f of x is like y. They're just saying find y when x equals 5. So all you're going to do is plug in that 5 and then evaluate. 2 times 5 plus 1, this answer is 11. So f of 5 equals 11. So it is the same as a y, but it lets you ask for a particular y, a y when you know what the x value is. So let's do like a couple examples here and then we're finished for today. So if f of x is x squared plus 2, and they want you to find f of 3, all you're going to do is go right to this and substitute a 3 right there in for x. So 3 squared plus 2, and then you're going to do the math. 3 squared is 9, 9 plus 2, this answer is 11. F of 5 again, I don't know why I'm stuck on the 5, but it's just 5 squared plus 2. 25 plus 2, my answer here is 27. If they ask for f of w, again, you're just going to take this w and substitute it in there for x. I will get w squared plus 2. And that's just it. And then my last one, f of a plus 2. I'm going to put a plus 2 just in this spot for x. So it's going to be a plus 2 quantity squared plus 2. So in these first couple ones, we had to actually evaluate. Here, I probably would expand that out. So it's going to be a plus 2 times a plus 2. Remember, that's like a FOIL. I'll get a squared plus 4a plus 4 plus 2. My final answer here is a squared plus 4a plus 6. All right, example 2. If you would like to try this one on your own, you can pause the video right now, and in 1 minute I will show the answers. So go ahead and hit pause if you're ready to give this a try. Okay, I'm just going to fill in the answers. 3 times 9 plus 4. 27 plus 4, is that 31? Here it's 3 times negative 4 plus 4, which will be negative 12 plus 4. I think that's negative 8. Hope I'm not making an error this time because I'm going kind of quick. Here it's 3 times x minus 4 plus 4. So essentially you just substitute in, but if it's a bigger algebraic blurb, you're going to sub that in, and this normally would distribute. So we're going to get 3x minus 12 plus 4. My final answer here will be 3x minus 8. How did you do? All right, example 3, our last example, is they can ask you to find f of 2 or f of 4 with a graph instead of an equation. So if they do that here, you're going to use this graph and just find f of negative 2. Again, remember, this is just saying what is the y when x is negative 2. So you're going to go to negative 2 on the x, go up to the graph, and read the corresponding y. This answer is 1. Again, go to 4 on the x-axis. 1, 2, 3, 4. Go to the graph, and then read the y. My answer here is negative 2. And then f of 1, you're going to go to 1, go up to the graph, and then read this y value. So 1, 2, 3, 4. This is 4. And that's all there is to that. All right, so that's it for today. We've got restricted domain, which were fractions, radicals, fractions with radicals, those 3. And then this f of x business with the function notation, just a fancier way for them to ask you for a particular y when you know the x and you just substitute in. Thanks a lot. Have a great night, and we'll talk to you tomorrow.